Hello, good day. So we are solving from a problem from May 2015. This is a sample of bolted connections, riveted connections. Okay. So the problem states that two channels are joined together by eight 25 mm diameter bolts in single shear, as shown in the figure. The bolt spacing is x1 is equal to 50, y1 is equal to 60, and the steel has Fy of 250 MPa and Fu 400 MPa. Okay. This is the channel properties. You have um, area, web thickness, tension. Uh, this is the code provisions of the allowable stresses depending on your failure modes code. Okay, allowable shearing stress of the bolt is also given 90 MPa and the bolt hole diameter is 27 mm. Okay, the question is find P based on bolt shear. So basically our bolts, the failure asked is the bolts will fail. The 8 bolts will be broken in one-way shear here. Okay, and there are 8 bolts 1, 2, 3, 4, 5, 6, 7, 8. Okay, by solving this problem, we have the formula P is equals to stress times the area contact. Just gonna write it here. P is equals to for stress of bolts, maximum stress of bolts times the area of the bolts. Okay. Okay. So maximum stress na kaya ng bolts is given here 90 MPa. 90 MPa, and the area of bolts is pi over 4. The diameter is 25 squared times the number of bolts, which is 8, and we have 1050 pi. 1250 pi rather. Okay, so substituting, you have the force P, you have 90 Newton mm. This is in mm squared, multiplied by 1250 pi mm squared. So you have cancelled mm and you have force P in newtons. And then the asked problem is, the choices are in kilonewtons. Okay, you can divide this by 1000 so that you will have kilonewtons. So the answer is 353.429 kilonewtons. So the closest answer is letter B. Okay. Okay, next question. Find P or the force based on bearing on the plate. So bearing on the plate, you have, when you say bearing, is the failure due to the elongation of the hole. No? So basically what will happen here is the hole diameter, when you apply a force P going to that direction, no? The bolt hole will extend, and then the hole will be larger, and then it will fail. No? Okay, the connection will fail. That's when it's bearing on the plate. Okay, so the formula still is force is equals to stress allowable times area. So P is equals to stress of bearing, stress and bearing times the area of contact, area contact of bearing. So the force bearing BR, let's say FBR, is given here is 1.2 FU, while the FU of the member is 400 MPa. So we have the stress bearing is equals to 1.2 FU, and FU is equals to 200. So FBR is equals to 1.2 times 200. That's not 200, that's 400. Okay, 400. So we have the stress allowable for bearing is equals to 480 MPa. And we have area of contact. Okay, the area contact is uh, the contact of the bolt, which is 25 mm, 25 mm times the thickness of the plate. So the thickness of the plate is, I think it's 12. So web thickness. Yes. So this is the thickness, and the bearing failure will happen here as you pull in force P. Okay. So 25 times 12 mm times the number of area contact. So there are 8 bolts. So you must multiply it by 8. You have the area equals to 2,400 mm squared. Okay, so we can substitute now to solve for P equals to the bearing stress is equals to 480 Newton mm multiplied by 2,400. This is squared mm squared divided by 1,000 so that you can have the force P in kilonewton. The answer is 1,152 kilonewtons. Okay, in the choices, you have letter D. Okay, that's the answer. If we proceed to the third question, find P based on block shear. So the block shear failure is like this. When you apply a load P, sample, going this direction, the plate will fail, will tear here. And then there are two modes that it will go straight or it will go diagonally. Okay, the most ways it will go diagonal, it will go to the nearest bolt hole, it will tear up. Okay, so there are two stresses acting on the block shear failure. So first is the force, stress. Okay, as you pull force P going to that direction, so the area of this plate, this will be removed and the connection will fail. So the first stress experienced by the plate is for stress in shear, and then the stress here will experience stress in tension. But there's a niche here. When you go diagonal, the failure will go diagonal. You should have you should add n times x squared over 4y. So you will add that length. Okay. Okay, we continue. I'm just going to write it here at the bottom. No, I can write it here again. So the third question. So block shear. So the force P will have force in shearing, area of the shearing, plus stress in tension times the area of the tension. Okay, so Fs is 0.5 of Fu, and Ft is equals to 0.3 Fu. Fu or Fy? Wait, let me check. Yes, Fu. So this is code provisions for code provisions. So sometimes this is not given, so you need to familiarize yourself of this formula. Okay, baliktad. So this is 0.3. So shearing 3 Fu and 0.5 of Fu. Okay, let me double check. Tension 0.5. Net area shear is 0.3. Okay. So you have 400 for Fu. So you have 0.3 times 400 and 0.5 times 400. So this is 200 MPa and 120 MPa. So you need to find the area of the shearing and the tension. Okay, so area of the shearing is here. This, the horizontal plane. So you just need to add x1, 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 x1. So 6 is x1. So 6 times x1 minus the bolt hole. Okay, this is one bolt hole. This is one whole bolt, one bolt hole, and this is only one half of the bolt hole. So you can say 2.5 bolt hole. That's the length. Now you multiply it by its thickness, and you multiply it by 2 because you have 2. There is 1 and 2. Okay, so that's the area of shear. Area shear is equal to 6 x1. X1 is 50. 50 minus 2.5 bolt hole is hole diameter is 27 minus 27. Okay, you multiply it by the thickness, which is 12, and then you multiply it by 2 because there are two planes that will shear at the top and the bottom. So area shear is equals to, okay, we made a mistake. There are only 5x1. So there are 5x1 only, because this another x1 is not included on the shear plane. There are only this 1, 2, 3, 4, and 5. So 5x1. You have AS area on the shear plane. You have 4380 mm squared. Okay, so that's the area that will experience shearing. So here in tension, this part, okay, we have diagonal. So basically, this is area is equals to length times the thickness, and then the length is equals to y3. This is y3, 3, and y3 is, I know that's y1. Y1 is 60 mm. Okay, that's y1. Okay, let me check. Yes, that's y1, 60 mm. So the length is equals to 2 L1 minus, this is only half of the whole, and then 1 whole of the whole, and then half. So 1 half plus 1 half plus 1 is equals to 2. So minus 2 times both whole. Okay, and then you must add because there is staggered failures happening. So plus, there are two diagonals. This is 1 and then 2. So you need to multiply 2. Okay, we're going to continue this part. Wait, let me just erase this. Plus 2 of this formula. The n signifies 2, and then the x is x1. So the x1 is 50. So that's 50 squared over 4y, which is 60. Okay, so that's the length. We have length is equals to, so you have 86.333. That's in mm. So substituting here in the area formula, you have length 86.33 times the thickness of, I think 12. That's 12. Yes, 12. That's 12. So you have area is equals to 1042 mm squared. 1042 mm squared. So okay, we substitute it to the formula here. We have the AS again, the value of 4380 mm squared, and the area in tension, which is equals to 1040 mm squared. So you can substitute to find P. Okay, so P is equals to FS 120, AS 4380 plus 200 times 1040. So you have P in newtons. So just divide it by 1000 to find kilonewtons. Okay. Okay, after calculating, we have 733.6 kilonewton. Okay, that's the force we need so that we can achieve block shear failure. So that's approximately 734. So that's the answer. Okay, so what does this implies as? So different modes of failure, different force P applied so that it can achieve that kind of failure. So basically, the failure that will achieve first is the shearing of the bolts, because the shearing of the bolts only requires 353 kilonewtons so that the bolts will fail, and it cannot reach the other modes of failure like the bearing and the block shear because it is greater than 353. Okay, so that's all. Thank you.